Hey math kids, today we're going to be in section 10F and talking about independent events. So if we have independent events, then this is true. So if we multiply individual probabilities of A and B, if that is equal to their intersection, then they're considered independent. So an example of two independent events would be flipping a coin. So we can get heads or tails, and then rolling a dice where we can get 1, 2, 3, 4, 5, 6. So the idea of independent events is if I get heads here, does it change my probability of getting a 1, 2, 3, 4, 5, or 6 over here? The answer is no. And so that's independent. Okay, and that would also hold true for this. Okay, so let's move on to example 14. It says a coin is tossed and a die is rolled simultaneously. Determine the probability of getting a head and a 3 without using a grid. So we want to do probability of getting heads and a 3. So that's the same as probability of getting heads and probability of rolling a 3. So this probability is going to be 1/2. This probability is 1/6. So the answer would be 1/12. 1 times 1 is 1, 2 times 6 is 12. Okay. Now, moving on. It says Carl is not having much luck lately. His car will only start 80% of the time. So they want us to draw a tree diagram. I'll just kind of cut to the chase on this one. So we're going to do a tree diagram, and we're looking at the car. So car starts, car doesn't start. It starts 80% of the time. It doesn't start 20% of the time. Then he has a motorbike. So you can try motorbike starts, motorbike doesn't. Motorbike starts, motorbike doesn't. Okay. It says that it starts 60% of the time. So 0.6, so 0.4, 0.6, 0.4. So the outcome here would be CM. Outcome here would be C, not M. Outcome here, not C, but M. And then not C, not M. And we want to know, what do we want to know? It says use the tree diagram to determine the chance that on the next attempt both will start. So a couple things are going on here. Let's zoom out a little bit. Okay, like that. So right here, the total probability would be 0.8 times 0.6. So we multiply those together and we get 0.48. Okay, this one's going to be 0.8 times 0.4. That's going to be 0.32. 0.2 times 0.6. 0.12. And then 0.2 times 0.4 is going to be 0.08. So I just kind of followed these paths to get to these numbers. Now, an important rule of probability is if we have our universal set right here, all the possible outcomes, they should add to 1. And so if we add these all on a calculator, we do 0.48 plus 0.32 plus 0.12 plus 0.08. You see that that does equal 1, so that means we have our entire situation. Okay. Now, we want to know the probability that both will start. And so that's just going to be this case where the car and the motorbike start. And so we've already figured that out. And so we have 0.48. So the probability of both is 0.48. Now the next thing, we have probability that the car starts. Here, I'm just going to write that in shorthand. Car starts and the motorbike does not. So we're going to look at that situation. Now, we only have one situation where that happens, which is this. And we've already figured out that the probability is 0.32. Okay, we're going to move on. Example 16, it says Liam rolls a six-sided dice twice. Determine the probability that exactly 1, 4 is rolled. Okay, so we're going to just say, let's just call it event A. So A is the event that a 4 is rolled. 4 is rolled. So if we create a tree diagram, we have a 1 in 6 chance of that happening. We have a 5 in 6 chance of event A not happening. And then when we roll the second dice, it's the same thing. 1 in 6 chance of it happening, 5/6 not happening. 1/6 happening, 5/6 not happening. And what was the question again? Let's see. Determine the probability that exactly 1, 4 is rolled. So if we do this, this would be AA. This would be A, not A. This would be not A, A. And then this would be not A, not A. So we want exactly 1. So these are the two situations we care about. So those are the only ones we have to look at. So what we're going to do is we're going to look at both of those branches. So we're going to go down this branch, which is going to be 1/6 times 5/6. And then we're also going to go down this one and this one, which is actually the same thing, just backwards. 5/6 times 1/6. So both of those are going to have the same outcome. It's going to be 1 times 5 is 5 over 36, and 5 over 36. And all we need to do is add these two green ones together. So we get 10 over 36. And then if we reduce that, divide by 2, we get 5 over 18. And so that would be the final answer on that. So that is the probability that we'll roll at least 1, or exactly 1, 4 when we're rolling 2 dice. If you need additional help, come to Math Lab. Until then, calculator.